particularly want to talk about if I'm building sampled FIR filters and noticing that the zeros you get can actually create all sorts of interesting transfer functions. And by just kind of saying, well, what happens where I specify the zeros, I can begin to get interesting kinds of behavior. And so I wanted to look at this for a couple different cases. And so I made 6 cases here, one with two of them with 2 zeros. In fact, the zeros are almost in the same place. One is at a point of pi over 4 and minus pi over 4. So things are symmetric. And then 3 pi over 4 and 3 pi over 4. I've got 2 cases here with 3 zeros, interestingly placed. And I've got 2 cases with 4 zeros. And so I wanted to kind of talk through this a little bit. What's really interesting in the one with the 2 with 2 zeros, one is that they're actually sitting at minus pi over 4 and 4. And remember that the point of a 0 is it simply says, at that point for an FIR filter, I know I'm at 0. So from a magnitude perspective, it's 0 at that point. And I kind of can like tie it down in terms of this response. Now, where the rest of this flows to, good luck, right? It's going to do what it's going to do. And you can kind of tell, because if I tie this sort of almost structure here, which is its frequency response and positive and negative frequency, right? So this goes from minus pi to pi. What you find is if I put the zeros here, minus pi over 4 and pi over 4, they certainly constrain this region, but then these take off up to the edges. Funny enough, if I do this at minus 3 pi over 4 and pi over 4, I get something that's a very nice sort of low-pass filter with a ripple on it. And so it definitely has I get something that's more low-pass to something that's more high-pass with sort of a response. But it's kind of interesting that it's kind of this fluid thing that I can move around. And so what happens when I have 3 zeros? Well, here's an interesting case. I put it at 0, pi, minus pi over 2, and pi over 2. Those are known when I do into the e's as j and minus j. Very cool. So then I can get something that gives me this sort of alternating sequence. And in each of these cases, once I create this, I multiply it out, I can easily get what is my impulse response. We're great. Interesting case, the next one though, is that instead of putting the 2 of them here, I put 2 here and a 0. I'm now going to have 2 of them there, and I'm going to put the other 0 at pi, which is also minus pi, because there's sort of a wraparound that's going on here. Okay, this is cool, right? So once I have that, I can then again come up with, and this gives me my sort of effectively, because I put all these together, I get kind of a sum of things, which is really cool. This is sort of your classical 4-input boxcar filter. Very typical low pass. This gives me kind of a form of a high pass. Again, this thing has this almost fluidness, where if it's like in certain spots, it'll be, if I tie things zeros down in one place, it's going to get bigger somewhere else. And then when I do it with 4 zeros, minus pi over 3, 0, and pi over 3, and then at pi, I'll get this sequencing of it. Obviously pick the pi over 3 because it fits really nice when combine 2 things. I get kind of a manageable cosine term. And I get a very interesting set of elements. Again, 4 points in my impulse response and nothing sitting in the middle term there. A similar thing if I do it with 0 and minus and plus 2 pi over 3. Kind of neat possibilities there. Plus there's also 0 at pi, and that's kind of cool. And notice just again how this gets there's a little bit of bumpiness in the middle, and then they come higher up at the high frequencies. Where here it's like I put the 0 and I locked it down at 0 and I get something in the middle. Interesting bandpass kind of response. So it's kind of cool to kind of see the number of things you get, but also the way the zeros kind of pin stuff down and the kind of pinning that you get in each of these situations.